Hi guys, in this video we're going to take a look at a additive rule, but this time it's an application to a deck of cards kind of question. So here I have a deck of cards. I just copied the image. And what you should know is that the standard deck of cards has 52 cards, so 52 cards total. And there are actually 13 of each, what we call suit. So like 13 clubs, 13 spades, 13 hearts, and 13 diamonds. So here we have, what's the chance that a card is a two of clubs? So what is two of clubs? Well, take a look at it. This is a two of clubs right here. There's only one card like that. So that's just going to be 1 divided by 52. Now, this one says it's a club or a two. So this is going to be tricky part. Okay, so this is going to be where you want to use additive rules. So here we have probability. Actually, let me draw with the black. So I want probability of club. So let's just say club or two. So this would be, if we use additive rule, this is probability of a club plus probability of a 2 and minus probability it's a club and 2. Okay, so here's what you want to do. First, highlight the clubs. What are the clubs? So clubs are all of these, right? So these are all clubs. How many cards are like that are clubs? Well, there are 13. So 13 divided by 52 would be the chance of clubs. Now, how many cards are twos? So now highlight the twos. Okay, so let me see if I can use a different color. So the twos are all over here, right? And how many of them are like that? Well, there are 4. So this should be 4 divided by 52. And then subtract, what does this mean? Club and 2. So remember, anytime in probability, whenever you see and, this means both at the same time. So it has to be a club and at the same time it has to be a 2. But the thing is, we already just found that this is this card. In other words, a 2 of clubs. So a card, in order for it to be a club and a 2 at the same time, that's just a 2 of clubs. So there's one card like that. So that would be 1 over 52. Okay, so let's see if we can compute that. So if I were to open up my Desmos calculator. Okay, and so let me see if I can resize it real quick. Okay, that's better. Zoom back. Okay, so it's going to be a club. Okay, it's going to be a club or a 2. Okay, so there are 13 clubs plus 4 twos and only one that's club and a 2. Okay, so let's see if we can reduce that. That would be 4 over 13. Okay, for this question, the next question says, so let me see if I can erase all of the marks that I have here. Just everything here. Okay, so, and then this part also. So now I want to find the chance it's a black 4. Okay, so let's see if we can find a black and a 4. Well, that would be these two cards, right? They're black and 4. So there are 2 of them are like that. So it's black 4. So 2 divided by 52. Okay, what would that be? So let's see, 2 divided by 52. Reduce that, that's 1 over 26. Okay, now this is saying a black card or a 4. Okay, so this is where we are going to use the additive rule. So we want to find probability of black or a 4. So how do we do that? First, we add probability of black. Hold on. Probability of black plus probability of 4 minus probability of black and 4. Okay, so first let's highlight all the black cards. Well, all the black cards are all of these right here. So there are exactly half of the deck is black. So the answer will be 1/2, or you can put 26 over 52 if you want. So this is going to be 26 over 52 because there are 26 black cards. Now, how many 4s are there? Let's also highlight the 4s. Okay, so the 4s are all of these guys, right? And so that would be add 4 divided by 52. And then we subtract black and 4. So again, the and means both at the same time. But I already know that that's it right here. So there are only 2 cards that are black and 4 at the same time. So that would be 2 divided by 52. So if I were to simplify that, let's see. So 26 out of 52 plus 4 out of 52 minus 2 out of 52, 7 over 13. All right, so the final one would be a heart and a black card. So again, let me erase all of the stuff here. Okay, and also here, let's erase that. Okay, so just bear with me for 1 second. Okay, so we want to know what is the chance it's a heart and a black card at the same time. So let's see, it has to be a heart and then a black card. Well, a heart is red and it's not possible for it to be black. So actually, this is just going to be 0. So a heart and a black card are what we call mutually exclusive. They cannot happen together. And so then for the last part, this is where we can use additive rule for mutually exclusive events. So this is just probability of heart plus probability of a black card. And that's it. We don't have to subtract anything because the overlap is just 0. It's not possible for it to be both. Well, how many hearts are there? Well, there are 13 hearts in the deck. And how many are black? Well, there are 26. So that, if I convert that to a fraction, would be 3 over 4.